Okay, so get this.
Yeah.
Imagine, a world where your phone
Mm.
isn't just for scrolling, but like a full-blown physics lab.
Okay.
That's what we're diving into today.
Cool.
We've got this
Yeah.
project called AEP's Virtual Lab.
I've heard of that one.
Yeah, it's from the Educational Technology Division of Ho Chong Institution in Singapore.
Wow, Singapore.
Yeah.
Interesting.
Pretty cool stuff.
Yeah, it's revolutionary, I think.
Yeah.
They're tackling the problem that we all faced back in school.
Oh, yeah.
Physics lab.
I hated those.
They could be a real drag.
Yeah.
Bulky equipment, time-consuming setups.
Yeah.
And sometimes things just wouldn't work.
Right.
This project aims to just flip that on its head.
Okay, I remember those days, but how are they turning a phone into a physics lab?
It's pretty wild.
It seems kind of wild.
They developed a series of apps,
Okay.
each one focusing on a different physics concept.
Oh, cool. What?
Like kinematics or moving car 1D,
Okay.
kinematics Y, or free fall, even monkey and hunter projectile.
Yeah.
Stuff you'd normally only see demonstrated with real objects.
Right, right.
So
they're taking these classic physics experiments and just putting them in your pocket.
Exactly.
Are these just basic simulations?
Not at all.
What?
They've woven in this really cool pedagogical approach. It's called
What is it?
mathematical modeling learning.
Interesting.
The idea is to push students beyond just watching what happens.
Right.
They actually get to tinker with the math behind the physics.
Oh, cool.
Yeah.
So instead of just seeing like a ball fall, they're figuring out the equations that describe why it falls the way it does.
Exactly.
I see how that would lead to a deeper understanding.
Exactly.
That's really cool.
It's all about making the learning active, not passive. And get this.
Yeah.
The principal investigator, Mr. Wee Lu Kang Lawrence, he developed this approach.
Wow.
In collaboration with the Open Source Physics Project.
Very cool.
Yeah. So these apps are actually built on software.
Oh, wow.
That anyone can use.
Really?
Modify and share.
That's amazing. So teachers could even customize these apps to fit their lessons.
Absolutely.
Wow.
And because it's open source, developers all over the world can contribute.
Oh, cool.
Making the apps better and more adaptable.
That's so cool.
This is way more than just prepackaged software. Yeah.
Oh, okay. Let's rewind a bit.
Okay.
What sparked this whole project? Why did they decide to go down this virtual lab route?
Well, think about those traditional lab sessions. They're often restricted by time, space, and even the availability of equipment.
Yeah.
This project just wanted to break those barriers and create a learning experience that's flexible and engaging, something students could access anytime, anywhere, and tailor to their own pace.
So they saw the potential of mobile devices to just completely transform physics education.
Yeah.
It makes sense. We're all carrying these powerful mini computers around in our pockets.
Right.
So it makes sense to harness that power for learning.
Exactly.
Right.
Smartphones and tablets are no longer just for communication.
Right.
They're capable of running some pretty sophisticated simulations, calculations, all of that.
And with this mathematical modeling learning approach, the apps go beyond simple visuals. Students can really dig into the underlying math and test out different scenarios.
Yeah, it's like having a personalized physics tutor right there in your hand.
Yeah, that's awesome.
Yeah.
It's giving students the power to explore and learn independently, which is so important.
Absolutely.
But I imagine there were some bumps in the road developing these apps.
Yeah, of course.
What kind of challenges?
Well, for one, making sure the apps worked smoothly across a ton of different devices and operating systems was a major undertaking.
Yeah, getting an app to work flawlessly on an iPhone and an Android
it's a nightmare.
Is no small feat.
Yeah.
And we haven't even talked about the design challenges.
Yeah, designs.
How do you make these complex physics concepts intuitive and visually engaging on a tiny screen?
It's like translating a whole physics lab into a language everyone can understand.
Right.
and doing it in a way that's actually fun to use.
Yeah, exactly.
They had to think about things like visual clarity, intuitive controls, even whether 2D or 3D was more effective for different concepts, things like that.
Yeah, it sounds like they needed a whole team.
Absolutely, not just physics whizzes, but education specialists.
Yeah.
Software developers.
A true interdisciplinary effort.
100%.
Yeah.
And all their hard work really paid off.
How so?
The AEP Virtual Lab project was even recognized by UNESCO, receiving the King Hamad bin Isa Al Khalifa Prize.
Oh, wow.
For the use of ICTs in education.
That's amazing.
Yeah, it's a serious accomplishment.
That's incredible.
It shows how much impact this project is having on the world of education.
Yeah.
And they're not stopping there.
Right.
They're already planning to expand the app library.
Wow.
And add even more features.
Like what?
Like integrating learning analytics with platforms like Moodle.
Cool.
You know, they're constantly working from these apps even more powerful learning tools.
So it's an ever-evolving project.
100%.
That's really cool.
Yeah.
But I'm curious about the specifics.
Okay, yeah.
They've developed several apps, each focusing on a different area of physics. Could you tell me a bit more about the kinematics or the moving car 1D app?
Absolutely. This one is a great example of how they're bringing complex physics concepts to life.
Okay.
It tackles the fundamentals of motion, things like velocity and acceleration.
Right.
But instead of just reading about them, you get to see them in action.
Oh, cool.
Yeah.
So you're not just memorizing definitions.
Exactly.
You're actually manipulating variables and seeing how they affect the car's movement.
Yeah.
That sounds way more engaging than staring at equations in a textbook.
Exactly.
Yeah, for sure.
Students can experiment with different starting conditions, apply forces, and then see how the car's position, velocity, acceleration, all of that changes over time.
That's cool.
And here's the cool part.
What?
The app even provides graphs.
Wow.
Of all these variables.
Really?
So you can visualize the relationships between them.
That's awesome.
Yeah.
It helps students build like an intuitive understanding of motion by seeing the math come to life.
100%.
That's brilliant.
Yeah.
And you mentioned before that it's all tied back to that mathematical modeling learning approach.
Alongside the simulations.
Okay.
The app encourages students to develop their own mathematical models of motion.
So cool.
They can use the data from their virtual experiments to derive equations.
That's so cool.
That describe the car's movement.
Wow.
It's like becoming a mini physicist.
That's awesome.
Yeah.
So it's not just playing around with a virtual car.
Exactly.
It's using that play to develop a deeper, more mathematical understanding of how things move.
Exactly.
I can see why this app has been so well received.
Oh, absolutely.
By teachers and students.
Teachers love the versatility. You know, they can use it for demonstrations, guided experiments, or even like let students explore independently.
Yeah. That's great.
And students find it much more engaging than traditional methods.
Yeah.
It's like having a virtual racetrack.
That's awesome.
Right there in the classroom.
This AEP Virtual Lab project seems like it's really pushing the boundaries of what's possible in science education.
It is.
But let's not get ahead of ourselves. We've only just scratched the surface.
Right. We've talked about the motivation behind the project, the innovative pedagogical approaches, the technical challenges involved.
Right.
But what about the bigger picture? How might these virtual labs change the way we teach and learn science as a whole?
That's a great question, and one that we'll delve into further in the next part of our deep dive. Yeah, we'll explore the potential of these apps to democratize access to STEM education, empower teachers with new tools and strategies, and inspire a new generation of scientists and engineers.
I love it.
All that good stuff.
Stay tuned.
Yeah, we're just getting started.
We're just getting started.
Exactly. As we were talking about that moving car app, I started thinking about all the students who never even had the chance to see a real physics lab, let alone experiment in one.
Yeah.
This project has the potential to change that.
Absolutely. That's one of the most exciting aspects of this whole project. We're talking about potentially leveling the playing field for students all over the world, regardless of their location or resources.
Imagine a student in a rural community, miles away from any kind of science lab, being able to explore physics concepts with just a smartphone. It's powerful.
It's incredibly powerful.
Yeah, it really is. Yeah. These apps could open up a whole new world of learning for students who might not have access to traditional labs due to geography, finances, or even disabilities that make physical labs challenging.
It's about breaking down those barriers.
Absolutely.
And making quality STEM education
100%
accessible to everyone.
Yeah.
And it's not just about the students, right?
Right.
Teachers can benefit.
Oh, absolutely.
From these apps too.
Think about it.
Yeah.
Teachers are always looking for new ways to make their lessons more engaging and effective.
Right.
These apps can be a game changer in that regard.
They could use them for demonstrations.
Absolutely.
Create interactive exercises.
Yeah.
Or even design personalized learning experiences for each student.
It's like having a whole team of virtual teaching assistants. Yeah, that's awesome.
And because these apps are digital, teachers can actually track student progress.
Right.
In a way that's not possible.
Yeah.
With traditional labs.
Yeah.
They can see where students are excelling, where they're struggling. And tailor their instruction accordingly.
Yeah.
That kind of personalized feedback can make a huge difference.
It's amazing to think about how this technology is not only changing the way students learn, but also giving teachers more tools and insights to support that learning.
100%.
It's a true paradigm shift.
It really is.
In education.
Yeah.
And while we're talking about changing the game, I have to ask, do you think these virtual labs could spark a whole new generation of scientists and engineers?
Interesting question.
I mean, could this be the thing that ignites a passion for STEM in someone who never thought they'd be interested?
I absolutely think so.
Yeah.
By making science more accessible and engaging, these apps have the potential to make it feel less intimidating and more like something anyone can explore and enjoy.
Exactly.
Who knows?
Yeah.
Maybe one of these apps will be the spark that leads to the next groundbreaking scientific discovery.
I love that thought.
It's about showing students that science isn't just about memorizing facts. It's about exploration, creativity, and problem solving. And these apps can be the gateway to that world.
Okay, so we've talked about all the amazing possibilities, but let's be real. There have to be some challenges.
Yeah, of course.
And limitations to this approach as well.
Sure.
Can't all be sunshine and rainbows, right?
You're right.
Yeah.
While these virtual labs offer a lot of promise, it's important to be realistic. For one thing.
Yeah.
They can't completely replace hands-on experimentation.
Yeah,
There's still something incredibly valuable about working with real equipment, learning lab techniques, and experiencing the unpredictable nature of scientific inquiry.
So it's not about replacing traditional labs entirely, but rather finding ways to use these virtual labs to enhance and complement them.
Exactly.
It's about striking the right balance.
100%.
Yeah.
And another challenge is making sure these apps are being used effectively. Just having access to the technology isn't enough. Teachers need training on how to integrate these apps into their curriculum, how to leverage their features, and how to assess student learning in this new digital environment.
It's about giving teachers the support and resources.
Exactly.
They need to really make the most of this technology. We don't want them to just have like a shiny new toy.
Exactly.
We want them to be empowered to use it effectively.
Absolutely.
And we can't forget about the digital divide. We live in a world where not all students have equal access to technology or reliable internet connections. If we're truly going to democratize STEM education, we need to address these inequities.
100%.
That's such an important point.
It is.
It's easy to get caught up in the excitement of these virtual labs, but we can't lose sight of the real-world challenges that still exist.
Absolutely.
And we also need to be mindful of the potential pitfalls of over-reliance on technology. It's crucial to remember that technology is a tool.
Absolutely.
And like any tool, it can be used in ways that are both beneficial and harmful. We need to make sure we're using technology to enhance learning, not diminish it.
Exactly.
It's about finding that sweet spot.
Their technology empowers both students and teachers.
You've hit the nail on the head. So while there are definitely challenges to navigate, I'm still incredibly optimistic about the potential of these virtual labs to transform science education.
Me too.
Yeah.
It's a powerful example
of
how technology, when used thoughtfully and strategically, can make a real difference in the lives of learners.
Absolutely.
It's inspiring to think about the possibilities.
It really is.
Yeah.
And, you know, as we're talking about all this, there's another layer to this project that I think is worth exploring.
Okay.
The AEP's Virtual Lab project is actually a perfect example of the power of open educational resources, or OERs.
That's right.
Yeah.
I'd love to hear more about that.
Sure.
What exactly are OERs?
Yeah.
And how do they fit into this whole conversation? Okay, so you're saying these apps as virtual lab are actually
part of a bigger movement called open educational resources. I have to admit, I'm not really familiar with that term.
Okay, sure.
What exactly are OERs?
Well, think of it this way.
Okay.
Imagine a world where educational materials, like textbooks, videos, even entire courses, are freely available for anyone to use, adapt, and share.
So instead of being locked behind expensive paywalls or restricted by copyright, these materials are open for anyone to access and use.
That's the basic idea.
That sounds pretty radical.
It is.
Yeah.
It's about breaking down those barriers to knowledge and making education a truly shared resource. And the best part is it's completely legal.
Okay.
OERs are released under open licenses that give people the right to use, modify, and distribute the materials without having to jump through a bunch of hoops.
Wow, that's amazing. I can see how that would be a game changer for students who can't afford expensive textbooks or for teachers who want to customize their lessons without worrying about copyright infringement.
Exactly.
But where did this whole OER movement come from?
It really started gaining momentum in the early 2000s. Fueled by the rise of the internet. And a growing awareness of the need for more equitable access to education. Think about it. The internet made it possible to share information. Instantly and globally. So it was only natural that people started thinking about how to use this power for education.
It makes sense.
Yeah.
The internet opened up a whole new world of possibilities for learning.
Absolutely.
But was there a specific moment when the OER movement really took off?
Well, a key turning point was in 2002 when UNESCO officially adopted the term open educational resources.
Wow.
And called for the global promotion of open access to educational materials.
So UNESCO has been a major force.
They recognized the incredible potential of OERs to democratize education and empower learners everywhere.
So UNESCO has been a major force behind this movement.
Yeah, absolutely.
But, you know, I'm still wondering, why should we care about OERs? What makes them so important in the grand scheme of things?
The impact of OERs can be huge. For starters, they can dramatically reduce the cost of education.
Wow.
Think about how much students spend on textbooks each year.
So much.
OERs. Those costs can be eliminated entirely.
Wow.
Freeing up money for other essential needs.
That's a major benefit. Especially for students struggling to afford a quality education.
And I imagine it could help level the playing field. For students from different socioeconomic backgrounds.
Exactly, but it goes beyond just cost savings. It
does.
OERs also offer incredible flexibility and customization.
Because they're openly licensed. Educators have the freedom to adapt and modify these materials to fit their specific teaching styles and the unique learning needs of their students.
So instead of being stuck with like a one-size-fits-all textbook, teachers can tailor the materials to create a truly personalized learning experience.
That's powerful.
That's powerful.
It is. They can remix and rearrange content, add their own examples and activities, even translate materials into different languages.
Wow.
It puts the power back in the hands of educators.
I see what you mean.
Yeah.
OERs give teachers the freedom to be creative and responsive to their students' needs. It's a whole new way of thinking about curriculum development.
It is.
And it's not just about
individual teachers and students.
Individual teachers and
OERs can benefit entire institutions.
Absolutely.
And even national education systems.
100%.
Wow.
By adopting and promoting OERs.
But
schools and universities can lower costs, improve the quality of their offerings, and create a culture of innovation and collaboration.
So it's a win-win for everyone involved.
Yeah.
Students get access to free, high-quality materials. Teachers have more flexibility and control. And institutions can save money and foster a more dynamic learning environment.
Right.
It's hard to argue with that.
And on a global scale, OERs have the potential to bridge educational divides and make quality learning accessible to everyone, regardless of where they live.
Right. Or their economic circumstances.
It's about making education.
It is.
A truly universal, right?
Exactly.
That's an inspiring vision.
It is.
It sounds like the AEPS as Virtual Lab project is a perfect example of this OER philosophy in action.
Absolutely.
Yeah.
The apps themselves are free to download and use.
Right.
And they're built on open source software.
Okay.
Meaning the code is also freely available.
So cool.
This open approach encourages collaboration.
Right.
And allows educators and developers from all over the world to contribute to the project, making it even better.
It's a beautiful example of what can be achieved.
It is.
When we embrace the idea of shared knowledge and collaborative innovation.
100%.
But are there other examples?
Oh, there are tons of examples.
Okay, like what?
Think about massive open online courses.
Okay.
Or MOOCs. Offered by platforms like Coursera and edX. These are university-level courses that anyone can take for free.
Free college courses?
Yes.
That's incredible.
Yeah.
What else is out there?
Well, there are sites like Khan Academy and CK12 that offer vast libraries of free educational resources covering practically every subject imaginable.
Wow.
And there are countless other initiatives and projects popping up all the time. From open textbooks to interactive simulations to lesson plans shared by teachers around the world.
It's amazing how much free, high-quality educational content
it really is
available online.
Yeah.
It really feels like the future of learning is shifting,
I think,
towards this open access model.
I agree.
Yeah.
And it's not just about quantity.
Yeah.
It's about quality, too.
Right.
Many OERs are created by leading experts in their fields and undergo rigorous peer review processes to ensure accuracy and effectiveness.
So it's not just like some random stuff floating around the internet.
Exactly.
It's legitimate educational material that's been vetted by professionals.
Right.
That's reassuring.
Absolutely.
Yeah.
And there are organizations like Creative Commons that provide the legal framework for sharing and reusing OERs. They offer a range of open licenses that give creators control over how their work can be used while still promoting open access.
So Creative Commons is helping to make the legal side of things clear and straightforward.
Exactly.
It's like a set of guidelines for open collaboration.
100%.
And thanks to these efforts, the OER movement is gaining serious momentum.
It is worldwide.
Governments, institutions, and educators are recognizing the value of open access and adopting policies and practices that support the use of OERs. It's a truly global phenomenon.
It is.
It's exciting to see how this movement is growing.
It is.
But I imagine there are still challenges.
Yeah, of course.
To overcome.
One of the biggest challenges is simply awareness.
Okay.
Many educators are still unfamiliar with OERs. Or don't fully understand the benefits they offer.
So we need to do a better job of spreading the word and educating people about the power of OERs.
100%.
And there are also challenges related to quality control and sustainability.
How do we ensure that OERs are accurate, up to date, and accessible over the long term? These are ongoing discussions within the movement.
It sounds like the OER movement is still evolving and figuring things out.
It is, but despite the challenges, the future of OERs is incredibly bright. As technology continues to advance and access to the internet expands, we can expect to see even greater adoption of OERs and more innovative ways to create and share educational resources.
It's a truly exciting time to be involved in education.
100%.
I completely agree.
Yeah.
This entire deep dive has been eye-opening.
It has.
We've explored the apps as virtual lab project, delved into the world of open educational resources, and really gotten a glimpse into the future of science education.
It's been a fascinating conversation.
It has.
I hope this has sparked some curiosity for our listener and maybe even inspired them to explore some of these resources themselves.
I second that.
Great.
And on that note, I think we've reached the end of our deep dive.
Sounds good.
Thanks for joining us on this journey of exploration.
It's been a pleasure.
It has.
Until next time, keep learning.
Yeah.
Keep questioning and keep pushing the boundaries of what's possible in education.
Absolutely. See you next time.